Welcome to Technology Comparisons Crashcasts. I'm your host, Sheila, and today we're diving into an exciting topic: Aeron Q versus Chronicle Q. Joining me is our expert, Victor. Victor, are you ready to unravel the mysteries of these high-performance queues?
Absolutely, Sheila. I'm excited to explore these fascinating technologies with you and our listeners.
Great. Let's break down what we'll cover today. We'll start with a brief history, then compare the key features of Aeron Q and Chronicle Q. We'll dive into their architectures, discuss real-world implementations, and compare them with similar technologies. We'll also cover common pitfalls and best practices. But first, let's kick things off with a quiz question for our listeners. Are you ready, Victor?
I'm all ears, Sheila.
All right, listeners. Here's your challenge. Which of these queues, Aeron Q or Chronicle Q, can handle a higher throughput of messages per second? Think about it, and we'll reveal the answer at the end of the episode. Victor, any thoughts on this without giving away the answer?
That's an intriguing question, Sheila. Both queues are known for their high performance, but the answer might surprise some people. It really depends on the specific use case and configuration. I'm looking forward to discussing the factors that influence their performance throughout our conversation.
Excellent. Let's start with the basics. Victor, can you give us a brief history of Aeron Q and Chronicle Q? Why were they created and how have they evolved?
Certainly, Sheila. Both Aeron Q and Chronicle Q were born out of the need for high-performance messaging systems in low-latency environments, particularly in financial trading systems. Aeron was created by Martin Thompson and Todd Montgomery around 2014. It started as an open-source project aimed at providing ultra-low latency messaging for high-throughput systems. Aeron Q is part of the larger Aeron ecosystem, which includes a full networking stack. Chronicle Q, on the other hand, was developed by Peter Lorre and his team at Chronicle Software. It was designed to be a persisted queue with extremely low latency and high throughput. The first version was released around 2013, and it has undergone several iterations since then to improve its performance and features.
That's fascinating. Before we dive deeper, could you explain what exactly a queue is in computing terms? I want to make sure our listeners have a solid foundation.
Of course, Sheila. In computing, a queue is a data structure that follows the first-in, first-out principle, or FIFO for short. It's like a line at a grocery store. The first person to join the line is the first one to be served. In software terms, items, often called messages or events, are added to one end of the queue and removed from the other end. Queues are fundamental in many areas of computing, especially in systems that need to process large amounts of data or messages in a specific order. They're crucial in scenarios where you need to handle operations that don't happen immediately, manage workloads, or coordinate between different parts of a system.
Thank you, Victor. That's a great explanation. Now let's compare Aeron Q and Chronicle Q. What are the key features that set them apart?
Great question, Sheila. While both Aeron Q and Chronicle Q are designed for high performance, they have some distinct characteristics. Aeron Q is part of a larger messaging system that includes network transport. It's designed for ultra-low latency, often used in real-time systems. It uses a special algorithm that allows for high concurrency without locks or waiting. It supports both in-memory and persistent storage options. Chronicle Q, on the other hand, is primarily designed as a persisted queue. It offers extremely low latency for both reading and writing. It provides a special file implementation for persistence that maps directly to memory. It supports replication and can be used as a journaling system. Both queues are optimized for high throughput and low latency, but they shine in slightly different scenarios.
I see. So, if I understand correctly, Aeron Q is more focused on real-time messaging, while Chronicle Q emphasizes persistence. Can you elaborate on how this affects their performance characteristics?
You're on the right track, Sheila. The focus on real-time messaging versus persistence does indeed impact their performance characteristics. Aeron Q, being part of a messaging system, is optimized for scenarios where you need to distribute messages across a network with minimal delay. Its design allows for extremely high throughput, especially in scenarios with multiple producers and consumers. Chronicle Q, on the other hand, is designed to save every message to disk by default. Despite this, it achieves remarkable performance through its clever use of memory-mapped files. This approach allows it to write to disk at speeds approaching that of writing to memory. In terms of raw throughput, Aeron Q can often achieve higher messages per second in pure in-memory scenarios. However, Chronicle Q's persistence doesn't significantly impact its performance, making it incredibly fast for a persisted queue. It's worth noting that the actual performance can vary greatly depending on the specific use case, hardware, and configuration. In some scenarios, Chronicle Q can outperform Aeron Q, especially when persistence is a requirement.
That's really interesting, Victor. You mentioned memory-mapped files for Chronicle Q. Could you explain what those are and how they contribute to Chronicle Q's performance?
Absolutely, Sheila. Memory-mapped files are a method of accessing files on disk as if they were in memory. When a file is memory-mapped, the operating system maps it to a region of virtual memory. This allows the program to read and write to the file using normal memory access operations, rather than using explicit file input-output functions. In the case of Chronicle Q, this approach offers several advantages. First, speed. Reading from and writing to memory-mapped files is often as fast as working with in-memory data structures, because the operating system handles the actual disk input-output behind the scenes. Second, persistence. Despite the high speed, the data is still saved to disk, providing durability. Third, zero copy. Data can be accessed directly from the mapped memory region, eliminating the need to copy data between disk and memory buffers. And fourth, large file handling. Memory-mapped files allow Chronicle Q to handle files much larger than the available physical memory. This clever use of memory-mapped files is a key reason why Chronicle Q can offer both high performance and persistence simultaneously.
That's fascinating. It seems like both queues have their strengths. Can you give us some examples of real-world implementations where each queue might be the better choice?
Certainly, Sheila. The choice between Aeron Q and Chronicle Q often depends on the specific requirements of the system. Here are some examples. Aeron Q might be preferred in high-frequency trading systems where extremely low latency is crucial, distributed systems that require efficient message passing across a network, and real-time data streaming applications like live video or audio broadcasting. Chronicle Q could be the better choice for financial auditing systems that need to save every transaction, event sourcing architectures where you need to replay all events from the beginning, and high-performance logging systems where you need to quickly write and retrieve log entries. Both queues are used in the financial sector, but you might find Aeron Q more in the front-office trading systems, while Chronicle Q might be more common in middle and back-office systems where persistence is key.
That helps put things into perspective. Now, I'm curious about how these queues compare to other similar technologies. Are there other high-performance queues out there, and how do they stack up?
Great question, Sheila. There are indeed other high-performance queue implementations out there. Some notable ones include, first, LMAX Disruptor. This is another high-performance queue developed by the LMAX exchange. It's known for its ring buffer architecture and is often used in financial systems. Second, Apache Kafka. While not a queue in the traditional sense, Kafka is a distributed streaming platform that can handle high volumes of data. And third, ZeroMQ. This is a high-performance asynchronous messaging library designed to be used in distributed or concurrent applications. Compared to these, Aeron Q and Chronicle Q often offer lower latency and higher throughput, especially in single-node scenarios. However, systems like Kafka excel in distributed, fault-tolerant scenarios. It's worth noting that the best technology often depends on the specific use case. For example, if you need a distributed system with built-in fault tolerance, Kafka might be a better choice despite potentially higher latency. If you need the absolute lowest latency for a single-node system, Aeron or Chronicle Q might be preferable.
That's really helpful, Victor. Now, I'm sure there are some common misunderstandings or pitfalls when working with these high-performance queues. Could you highlight a few and how to avoid them?
Absolutely, Sheila. Here are some common pitfalls and misunderstandings. First, assuming higher throughput always means better performance. While both Aeron and Chronicle Q offer high throughput, it's important to consider other factors like latency, persistence requirements, and system complexity. Second, neglecting proper tuning. Both queues require careful configuration to achieve optimal performance. For example, not setting the right buffer sizes or not aligning data properly can significantly impact performance. Third, ignoring hardware considerations. These queues are often bottlenecked by hardware. Using slower disks with Chronicle Q or a congested network with Aeron can negate their performance benefits. Fourth, misunderstanding persistence guarantees. With Chronicle Q, people sometimes assume all data is immediately saved to disk, which isn't always the case depending on the configuration and operating system level caching. And fifth, overcomplicating the architecture. Sometimes developers try to use these high-performance queues where a simpler solution would suffice. It's important to benchmark and profile to ensure you actually need this level of performance. To avoid these pitfalls, it's crucial to thoroughly understand the documentation, benchmark your specific use case, and consider the entire system architecture, not just the queue component.
Those are great points, Victor. Do you have any best practices or tips for developers working with these queues?
Certainly, Sheila. Here are some best practices and tips. First, proper sizing. Ensure your queue size is appropriate for your use case. Too small, and you risk overflow. Too large, and you waste resources. Second, batch operations. Both queues perform better when operations are batched. Try to enqueue or dequeue multiple messages at once when possible. Third, avoid contention. Design your system to minimize conflicts between producers and consumers. This often means using multiple queues for different purposes. Fourth, use direct buffers. When working with Aeron, use direct byte buffers for better performance. Fifth, align data. Ensure your data is properly aligned in memory. This can significantly impact performance, especially on certain hardware architectures. Sixth, monitor and tune. Regularly monitor queue performance and be prepared to adjust parameters based on observed behavior. Seventh, understand the trade-offs. Each feature or configuration option often comes with trade-offs. Understand these thoroughly before making decisions. And eighth, test thoroughly. Given the complex nature of these systems, thorough testing, including stress testing and chaos engineering, is crucial. Remember, these are powerful tools, but they require careful handling to get the most out of them.
Thank you, Victor. Those are excellent tips. Before we wrap up, do you have any interesting facts or memorization techniques to help our listeners remember the key differences between Aeron Q and Chronicle Q?
Certainly, Sheila. Here's an interesting fact. The names of these queues actually give us a clue about their primary focus. Aeron is named after the chemical element aeron, which is a noble gas known for its stability and lack of reactivity. This reflects Aeron's focus on stability and predictability in high-speed messaging. Chronicle, on the other hand, refers to a record of events, which aligns perfectly with its focus on persisting data. As for a memorization technique, you can use the acronym ACE to remember the key differences. A, Aeron for asynchronous messaging. C, Chronicle for continuous logging. E, evaluate based on your specific needs. This reminds us that Aeron excels in asynchronous messaging scenarios. Chronicle shines in continuous logging and replay scenarios, and the choice between them depends on evaluating your specific needs.
That's a great technique, Victor. Now let's summarize the main points we've discussed today about Aeron Q and Chronicle Q.
Certainly, Sheila. Here's a summary of our key points. Both Aeron Q and Chronicle Q are high-performance queue implementations designed for low-latency environments. Aeron Q is part of a larger messaging system and excels in real-time distributed scenarios. Chronicle Q focuses on persistence using memory-mapped files, offering both high performance and durability. The choice between them depends on specific requirements. Aeron for ultra-low latency messaging. Chronicle for high-speed persistent queues. Both queues require careful configuration and understanding to use effectively. Common pitfalls include neglecting proper tuning, ignoring hardware considerations, and misunderstanding persistence guarantees. Best practices include proper sizing, batching operations, avoiding contention, and thorough testing. Remember, while these queues offer exceptional performance, it's crucial to evaluate whether such high-performance solutions are necessary for your specific use case.
Thank you, Victor. That's a great summary. Now it's time to reveal the answer to our quiz question. Which queue can handle a higher throughput of messages per second? Aeron queue or Chronicle queue?
The answer is, it depends. In pure in-memory scenarios, Aeron queue often achieves higher throughput. However, when persistence is required, Chronicle queue can match or even exceed Aeron's performance. The actual throughput depends on the specific use case, hardware, and configuration. This highlights the importance of benchmarking and testing in your own environment rather than relying on general comparisons.
Excellent point, Victor. Thank you for sharing your expertise with us today. Listeners, we've only scratched the surface of these fascinating technologies. If we had more time, we could have delved deeper into topics like the internal architectures of these queues, advanced configuration options, or how to integrate them into larger system designs. If you enjoyed this episode, please subscribe to Technology Comparison's Crashcasts and leave us a rating. Your support helps us continue to bring you in-depth technical comparisons. Until next time, keep queuing and computing.